All right, uniform motion with distances. So now these are people's favorite problems here. But when we have any sort of motion, we have to remember that distance is nothing other than distance is equal to rate times time. Or sometimes I think of dirt here, okay? So DRT, so dirt. And if I know that, right, algebraically it's simple enough to rearrange these where I can say, well, I could also say that time is distance over rate, okay? And that I could say also that rate is distance over time. That's not too much of a stretch, I don't think, right? Because I just rearranged my equation, right? That's how we learned how to do our algebra a while ago. So that's not too hard. So then, right, how do you solve these? Well, I just give 2 tips here, right? If I have a simple diagram of what's physically happening, then it helps me kind of calibrate what I'm going to do. Okay, so I can make a simple diagram. Okay, and then next here, and then I can just, seems simple enough, right? But I can just write what I know, right? So write what you know about each one, right? So write what you know right? So I have something about D, right? I have something about rate maybe, and I have something that I know maybe about time, okay? So let's just read example 2. So example 2, I'll read it for you. You can, if you're following in your book, you can also see it. But try not to read into the problem where they solve it, right? But it says, Atalanta ran 4 times as fast as her challenger. Okay, so this is an interesting name anyway, but anyway, Atalanta. So Atalanta ran 4 times as fast. So what does that mean? Well, it means that she ran faster, right? 4 times, as fast. So, what can I say about the rate? Well, I can write that before I finish the problem, I guess, if I want to. But she ran 4 times as fast as her challenger, and that's all it said is her challenger. Then I can just say that the rate of Atalanta is 4 times as fast as her challenger, right? So I can say 4 times her challenger, like this. Okay, and then it says, in fact, she ran 80 miles. Okay, so she ran 80 miles in 2 hours less than it took her challenger to run 28 miles. Okay, so she ran 80 miles. So we can say that her distance was 80 miles. Okay, and here, right, my units, I'm not going to convert to units, but I can put 80 here, 80 miles. And then it says something about her time. It was 2 hours less than it took her challenger to run 28 miles. So that 2 hours less. So what do we say about time then? Well, what do we say about time? Well, what do we know? We know that the time of Atalanta was not equal to her challengers, right? What was it? Well, it was 2 hours less, right? So then where does that 2 hours go? Well, it doesn't go on Atalanta's side on the left side. It comes right here and says, well, it's the time of her challenger minus 2. Okay? And then we know that her challenger, right? What about her challenger? Her challenger. So we'll just call him Challenger. Maybe his name is even Challenger, okay? Challenger is the distance we're given is 28 miles. Okay, so I can put 28 mi, period. And it does not say anything about the distance there. It just says it just says in 2 hours less than it took the challenge to run 28 miles. How fast did each of them run? Okay, well then what do we got to do here? Well, we know that the rate of her challenger, we could just simply write it as the rate of her challenger, okay? And I'm not going to elaborate too much, but basically I don't want to rearrange this guy up here, right? I want to keep this one like it is. So now how do I use my equations here? Well, what do we know again, right? Well, I know up here that distance is rate times time. Time is distance over rate, and then rate is distance over time. So I have this equation here, this kind of longer equation here, where time of Atalanta is time of Challenger minus 2. I'm going to use this guy. Now, how can I use this? Well, what do I know about time? I know that time, again, is what? Well, what did I say before? Time is distance over rate. So if time is distance over rate, let's try to apply this, right? So let's try to apply it down here. And say, okay, well, time of Atalanta must be distance of Atalanta over rate of Atalanta. And it's equal to the time of her challenger. Well, time of her challenger is also distance of her challenger over the rate of her challenger. And then I can subtract 2. But I actually know a bunch of these things, right? Don't I? I know that the distance of Atalanta is 80, right? So I know this is 80, and the rate of Atalanta is 4 times RC. Okay, so I know it's 4 RC. And then I know the distance of the challenger is what? Well, it was 28, right? It only went 28 miles. And the rate of her challenger, well, it's actually still RC, so I might as well keep it RC. And I'm subtracting 2 from this. Now, this might not look similar in a lot of ways to the other problems, but hopefully it does, right? What do I see here? Well, what I see, and this is after looking at problems for a while, right? But you can see that I have one variable here, right? And it's sitting all by itself here. It's all lonely, okay? And so I need to figure out some way to isolate this, because then I can find out the rate of her challenger. And if I find out the rate of her challenger, then I can find the rate of Atalanta. And so I can find out that this is my least, or this is part of my least common denominator, right? Because my least common denominator is simply 4RC. And right there's kind of a squish there. And so what I can do here is say, well, then let's multiply everything by 4RC. And I can do this, right? Why? Because I have an equation. I can multiply both sides by something, right? Because I'm changing both sides by the same exact amount, right? So then I can say 4RC here. And what happens? Well, my RC cancels right here, and I'm left with actually 4 and RC, right? For this one, cancel all the way out, and I'm just left with 80. And then what do I left with here? I have equals. My RC cancels, but I have my 4, so 4 times 28, 4 times 30 would be 120, so 4 times 28 would be 112, okay? And then I'm subtracting 8 RC. Whoops. 8 R sub C. And then I rearrange this, right? Because if I have this, right, minus 112, right, because I want to make sure that it gets on the other side, minus 112, I'm left with minus 8 RC is equal to, what is that, except for minus 32, right? And then what do I do from there? Well, if it's multiplied by minus 8, I simply divide by minus 8, right? Because if I do minus 8 divided by minus 8, I get 1, and I divide by minus 8 here. And it's good that I have negative divided by negative, right? Because then that gives me that the rate of her challenger was simply equal to 4, right? Or 4 miles per hour, right? And if the rate of the challenger was 4 miles per hour, right, they asked me to find how fast each in the run. Well, that's one of them, so I can say, okay, I can box that in. And then the rate of Atalanta, because it's 4 times, right? I can scroll back up and you can see, right? What did we say? We said it's 4 times the rate of her challenger. Well, what is 4 times 4? Well, 4 times 4 is just 16, so I can say 16 miles per hour. And that finishes that problem. Oh, actually, what did I not do? I didn't write a diagram, but I can draw a diagram for this, right? Sometimes you might not think it's necessary, and you don't have to draw the diagram, right? But it helps me because I can say, well then, what do I have here? I have the rate of Atalanta was 80, right? And then the rate of her challenger was only 28, so you can kind of see physically what was going on here, right? But it's not completely necessary to draw the diagram. It just helps me, especially if the problem is a little more complicated, to visualize what's going on.